Solid Edge continues to improve in areas which help our customers to achieve faster design times by providing state-of-the-art tools. Let's take a look at these advancements in the area of digital mockup. Depending on the terrain, this robot may need a different kind of tread. So we can quickly change our focus to the area of the drive system. You can see the belts have already been added, but we also need to add a tread to the assembly. With this tread part, we can use both the belt and an assembly sketch as our paths to follow along. Just applying a face-to-face relationship there, quite simple. We'll use the sketch next. New in ST8 is the ability to apply a path relationship, which allows you to set the origin but also create an offset, giving you full control of the placement of the part. And there's the centre for the top sketch. And here we're looking at the offset. I'll check the offset out. It's some arbitrary value. We'll just flip the direction so the offset's on screen. And let's change that to 500. And then back to 400. That's quite neat. In order for us to replicate the tread around the belt, we can use the pattern along a curve. Obviously, this command offers several options to help you achieve the pattern you're looking for, but a new option within the command in ST8 is the ability to create a chord length pattern, which gives you the correct results when tracking a squared edge part around a curve without having to create any awkward construction geometry. Just me mucking around here trying to find the centre point. There we go, of the edge, and we can see that those parts have mated exactly to the belts. Let's replicate that on the other side, and there we go. So we need it on both sides. So we use the second curve path to offset the pattern. Again, having the right tools makes this type of work quick and easy. We mentioned digital mockup earlier, and the tools we've used so far to help us set this up. Because we want to synchronize the belts with the wheels, we can quickly set their driving variables to be equal. Notice here we will set the tread variable to drive wheels, which sets the value to 300. Then to simulate the treads rotating around the wheels, we need to set up a motor to drive these components. For ST8, we've added a new motor allowing us to drive variables from the variable table. When we run the command, we select the variable, give it a speed and a limit, and the variable table motor is created. You've seen how easy it is to drive components from the variable table, but let's take a look at another new capability offered to help you promote and use adjustable assemblies. As we change our focus to the top of the robot, you'll notice we've placed two of the same mini-arm sub-assemblies. Once made adjustable, we now have the option to override relationships, which basically moves the selected relationship to the top level assembly, giving us full control over these relationships. You'll notice both of them are available at the top level, those angular relationships. To better understand this, let's go back to the variable table where we can set up a quick formula to drive the same angle for each arm in different directions. Just looking for the name of the variable for the first arm, and we're going to put a formula in. we've got a formula called a variable called arm lift, which we'll use in our formula for the angle relationships. The first relationship is 90 degrees plus the arm lift value, and the second is 90 minus. So this means that they'll move in opposite directions. Once set up, we can easily change the arm lift value. I'll just move that down so you can see it. And you'll notice as I change the value that the arms will move in opposite direction. Powerful tools that provide the flexibility needed to get the job done right the first time. Now, using the new variable table motor command, we can also set these commands into these variables into motion. There's the variable motor command. We just pick up the variable, which is the arm lift, and apply a speed and a duration. And because it's an angle, the speed's in degrees per second. To better visualize these parts in motion, Simulate Motor command allows you to set up and run your animation using the motors we just defined. You'll also notice that the motors are defined within the assembly. Here's our two motor variables. Once we're in the timeline, many tools are provided to help you simulate your designs. For example, you can reverse the direction of the motors or simply apply a copy and mirror to get them to move in both directions. Then just click on play to see the results. Speed that up a little bit. As you can see, there's a great deal of processing going on behind the scenes, so it's not real-time speed that we get here. However, if you want the real-time speed displayed, we have a way of doing that. Let's take a look at the Save as Movie, and we can save that in either WMV or AVI format. Here are the results of these components being put into motion. I've added an angular component as well to the base of the arms. Being able to digitally mock up your designs within Solid Edge just got easier in ST8. Powerful tools and ease of use gives you everything you need to complete your designs faster and more accurately.